Hi, I'm going to show you how to make a constant velocity loop. So if you're watching these videos in order, you already know how to make a ball. So let's make a sphere and call it ball. So I'll just to create our object to begin with, so I'm going to say ball equals sphere. Let's give it an initial position of 0, 0, 0, and let's give it a color. I kind of like cyan, so let's start with that one. I think I've got the right number of parentheses just to make sure it works. So I'll click on run there. There's that nice ball. And now we're gonna create a loop. So maybe I'll do nice tags here. So make our ball. Initial values for our loop. So, well, I guess we need this ball to start from somewhere and end somewhere, things like that. I think I'm just going to have the ball move horizontally. So the only thing we're going to be doing is changing our x value. So I'm going to say, let's start the position at 0 to begin with. So this is our starting position. And our constant velocity, I just want to remind ourselves, our constant velocity model in math, I'll go like this. Our constant velocity model looks like x, the position, was equal to vt, which is velocity times time, plus the initial position, so x0. So that's what it looked like in regular, I'll put quotation marks, regular math. So what is this going to look like inside of our loop? Inside of our loop, it's going to be, well, we don't have to say x and x0. So x0 or x0 would be like the original position, and x would be the position after some amount of time. So what we're going to be doing is we're going to be running our loop each time, and we're going to use a Python version of that. So Python, or computational version, is going to look like, so we're still going to have x is going to be equal to, and v, and I'll have to say times for times, and some amount of time. And I think we need to talk about that a little bit, because it's not going to be the entire time, because we want to have it animate. If we just did the entire time all at once, the object would just go to its final spot. So if I wanted something to move for 5 seconds, I don't think I want to put 5 in there. I'm just going to write out some amount of time plus our original position, so that'll be x. So every time we run the loop, the x on the right hand side will be the position before we've moved it a little bit, and the amount that it's going to move is the velocity, which is how fast it's moving, multiplied by how much time goes by in each part of the loop. Finish my little comment there. So that those 3 quotation marks is kind of like hashtagging all of that out, and it turns green. So what I need to do is figure out what's the velocity then of this ball. So maybe I'll use the letter v for this. So v is going to be equal to its velocity. Let's give it a velocity of, say, 3. So this means the velocity of our ball. Time should start at 0, I think, in this case. And I think we're ready to start our loop. Let's make a loop. So we're going to say while, I don't know how long we're going to make this. How about while time is less than or equal to, let's say 5 seconds. Okay. Change the value if you want. Okay, so that's that 5 there is something that you can change if you want to make the time go for longer or shorter. Oh, I forgot the colon at the end of the 5. So I'll put the colon there. I always forget that one. And then when I hit enter, it didn't indent right away because I put that comment in there. So I have to hit the tab key myself. So, well, normally what we would do in our loop is we would be printing every time, right? But now we don't want to print. What I want to do is change the ball. So I'm going to be changing the ball each time, and I'm also going to be incrementing time. Okay, so what about the ball am I going to be changing? I'm going to be changing its position. So how do I change its position? So I say ball.position equals, and remember, just like originally, position POS is a vector like that. I'm going to say vector. And now the x position is the one that's going to be changing. So I'm going to say x. So every time the x value changes, every time I iterate through the loop, x will be changing just by a little bit. So that value of x will change. And that's really what makes the ball move across the screen. I'm not going to do anything with y or with z right now. So that will change the position, or that will redraw the ball at position x. You'll notice the very first time I go through the loop, x is still 0, so it's not going to make any difference. And now I need to increment the position a little bit. I need to use that Python version here. So I'm going to say x equals v times. Now, how much do I want time to increase by each time? If I make time like 1 second, for example, actually, let's try that. I'm going to say v times 1. So what I'm going to do is going to be drawing the ball, and a second is going to take place every time it loops. X is equal to v times 1 plus x. Okay, so if I'm thinking about this, what is my velocity? My velocity is 3. So the first time the ball is going to have a position of 0, and then the second time it's going to be, okay, so this was 0. It's going to be moving 3 meters in 1 second. So it'll be moving 0, and then the next time it'll be 3, the next time it'll be 6, next time it'll be 9, and so on. It's going to be jumping by 3. The other thing I need to do in this loop is to make sure that there is a pause in here, like that the rate is slower. So I'm going to use the word rate. It's kind of like sleep. So rate is going to be equal to how many loops per second I'm allowing it to do. So I'm going to say rate is going to be equal to, I don't know, say 2 loops per second. I'm going to keep it quite slow. Maybe I'll say 4, so it's not too slow. Okay. Let's try this. See if this works. I'll run this program. Okay, so it looks like it's getting smaller as it's going off to the right. Or it looks like it's just getting smaller. Oh, is it still getting smaller? If I look at this, my while time is less than or equal to 5. Oh, I forgot to change time each loop. So t was not getting changed in my loop. That's why it just kept on getting smaller and smaller. So I need to say time is equal to time plus. So I need to increase time. And really, it should be the same amount that I'm using there. So in 23, I'm saying redraw the ball after 1 second, because it's going to be moving at some velocity in how many meters every second, in this case 3 meters every second. If I write a 1 in there, that means it's redrawing it every second. So I should advance time by 1. Okay, let's try this one more time. See the ball moving to the right. So why, and it stopped this time. So why did it stop? Or actually, maybe another question is, why does it just look like it's getting smaller? It doesn't really look like it's going to the right. So maybe I'm going to put in a little test piece in here. I'm going to say print x. So just to tell me, what is that horizontal position? So when I run it, it's showing up on the bottom. I don't know if it shows up on your screen as much, but it says 3, 6, 9, 12, 18, and so on here. Some of the other ones. So here, can I make this? There. Okay, now I got it in there. So here's what it says on the bottom. The x position is going 3, 6, 9, 12, 15, 18. So I wonder why it's acting like this. I'll do it one more time. It's going to the right, and then it looks like it's getting smaller instead of continuing to go to the right. So the answer is that the camera in Glowscript is tries to make sure that the object is still in the screen. So it goes to the right, and then it continues to go to the right, but the camera backs up so that you can still see it. So that's what's happening there. If I say, let's start the position at 0, you know what? I'll just leave that. But the other piece is that it's not really running that smoothly. It's kind of jerky. So instead of having it go every second, it'd be nice to have it go every 1/10 of a second. So over here I could put 0.1, and then I'd have to go over here and do this at 0.1. I could see myself having to change this value fairly frequently. I'm going to run this again, see if it looks smoother. It's kind of smoother. It's not bad. One thing that's slowing it down is my printing. So if I delete that line, try it again and I'll run it again. Yeah, it still doesn't look very smooth. So I think I should change that 0.1 to something smaller. So if you find yourself coding and you have to go and make frequent changes and you're doing the same thing a bunch of times, in this case I'm changing that 0.1, it's nice to create a variable for that. So this is really how much time is being incremented every loop. So it's the change in time. So I'm going to use dt for this. So d, you can think of this as delta t, the amount the time is changing every time. So I'm going to write 0.05. And then over here, instead of saying 0.1, I'm going to put in dt to represent that. Put it over here too. And the other thing I was thinking is that it's getting kind of slow. So I changed dt to a smaller amount, so it should be less jerky, and I've made the rate, maybe I'll say 10. I've made the rate faster so that we won't be watching it quite so long. So let's run it this time. That's not bad. The last thing, I like to get rid of that having it go smaller as it gets to the right. So what I'm going to do is I'm going to create another object right in the very beginning. Maybe I'll make a box. Box equals, okay, how do you make a box? So 3D object, look at a box. You give it a position, and the position is the center of the box, and then you give it a length, a height, and a width. So I'm going to just copy this line and then change it. I'm going to go like this, and then paste it in there. So my box is going to start off with the center will be at 0. And I want to have it just a little bit lower on the screen, so I'm going to give it a value of negative 0.5 on the y, and it's still z0. I don't need to change the axis. I'm just going to delete that. And then the size of this, let's make it quite big. Let's say in the x direction it's going to go 10. Or what's the largest that this is going to get? It's going 3 every second, and it's going 5 seconds, so it's 15. So I'll make this go 15. I'll give it a height of 0.2, not very big at all. 0.2. It will be white by default. Let's see how I did if I run this thing. There we go. So I've got this line. So what drawing that line originally does, and there you can see that effect of the camera pulling back. So by drawing that line to begin with, it causes Glowscript to pull the camera back a little bit so that the object moving to the right, it looks like it's moving to the right. It goes farther than I want though, so the ball goes farther. So I'm going to say that this thing has a size maybe of 25. Let's run this program again. So it's moving along. So it gives you a sense that this ball is moving along that line. And the animation isn't bad. It's not great. It looks a little bit jerky. Still goes a bit past. Alright, so I hope that is kind of helpful. See if I can get that into there. So this is your basic constant velocity loop. The things that are going to stay the same, I think, is that line 26. That's our computational model. So originally I wrote some amount of time, so really it's like dt is that small amount of the loop. This is really what drives everything, is that line 26. And feel free to change values to make other things happen. So if you want to make it move forward or backwards, you can change the velocity forwards or backwards. All right, I hope you found this helpful.